Hello everyone, my name is Gaurang Gupta and today we will make a ML project which is Netflix stock price prediction. Here is the dataset. I will link this in the description so you can see we have the data description here. It is a quite short description so you can read it. And here is our data. We have some columns here. You can see that the date, the there are several attributes like date, high, low, close, and there are some more parameters. You can see them. So what we have to do is we have to predict this close price. We have This is the price at the end of the day. And what happens in trading is that for a particular day there are four things we see: high, low, close, and open. So this close price is what we have to predict. So let's start coding. First we will import all the necessary libraries. So import numpy, snp, import pandas, spd, import os, import matplotlib, pyplot, splt, import sklearn.metrics, import mean squared error, mean absolute error. uh, it should be from sklearn.metrics, import mean square and mean absolute error. Now we will import our models from sklearn.linear model, import lasso, sgd, regressor, ridge, from sklearn.svm, import support vector machine, from sklearn.preprocessing, import standard scaler, from sklearn.ensemble, import random forest regressor, from sklearn.gaussian process, import Gaussian process regressor, from sklearn.gaussian Gaussian Gaussian process dot kernels, import dot product and white kernel, sklearn.tree, import decision tree regressor, from sklearn.neighbors, import neighbor regressor, sklearn.neighbors, put radius, neighbor regressor, sklearn dot model selection import train test split from import cbond as SNS. Now we have imported all the necessary libraries. So now let's import our data. So to import our data, I'm using this code. Again, this code is the default code which Kaggle automatically gives when you start a new notebook from this place, from a data set. If you click on this, this will give you a default notebook which has this code. So I'm copying that same code, and when we will run it, it will give the path of the file. So let's import the data. So data equal to pd.read csv, and then we will copy this path. Let me copy it, and then to check data.head. Now we will run it. Here you can see we have all the data. So date, open, high, low, close, adjusted close, and volume. We have all the attributes now. So now let's move on to data visualization. To start it, I will first put data.describe to check what our data is all about. So you can see it gives us many parameters about each column: the count, mean, standard deviation, minimum of a column, maximum of a column, 25%, 50%, and 75%. Now, before we move on, first I need to point out that here you can see we have numbers. So again, we can look what is happening, but it is kind of difficult. So let's see in a better format. So here you can see what I have done is I've given this tabular format of data a gradient, so we can see what is actually happening. I used the green color, but you can again use any color, and I have only used 5. You can use any number of rows. Like here I have switched the 5 to 10, so it is easy to see what is happening and make correlation with the same column, that yes, the data is increasing or decreasing or any other thing you want to see. So I will set it back to 5. Now we will plot the graphs for all these 6 attributes: open, high, low, close, adjusted close, and volume against it, so that we can get an idea that how the stock is moving or has moved for the given period of time. So let's start it. Plots 2, 3, fixed size equal to 20, 10. Again, you can change the fixed size. I have used 2, 3 subplots. So ax dot plot data open x1 dot set label set x labels will be the day, and just so that we can see clearly, I'm setting font size equal to 15, and ax1 dot set y label is open, and again font size will be 15. So let's run it, see what we got. So here you can see we have all the 6 subplots, but only we have populated the first subplot. Wait a minute. We have only populated this first subplot, this AX1. So you can see the movement of stock here easily. So we will do it for rest 5 attributes also. So let's do it. am changing the color so that we can see more clearly. So I am giving this green color. You can see we have plotted the height. So now I'm going to populate every graph and then run it. So now we have plotted every graph. You can see all the graphs are present. Mm, Here is the code. Now let's move on to data pre-processing. First we will print how many columns and which columns are present in the data, and you can also print the shape of data. Now we will first scale it accordingly. So I'm using the standard scaler. You can use any scaler. There are many scalars like min, max scaler and all that. So you can use that, but I'm preferring a standard scaler. So first I will drop the date, and the axis will be 1, and the in place will be true. Then data dot s sorry. Then we will update the data with std.fit_transform data. So let's see by running it. Here you can see we have all the parameters which were present in original data before removing the date section, and we have also have shape. So now we will wait a minute. We will declare a new parameter, new data, equal to pd dot data frame data, and now I will print new data dot head. Now here you can see the previous names of the columns like open, high, low, close. We don't have that. Now we have zero based indexing, 0, 1, 2, 3, 4, 5. So the main reason I printed this is so that we can see which are the parameters, or which is the parameter for which we have to do the prediction. Here you can see if this 0 is now open, 1 is close, 2 is low, and 3 now is our close. So this is wait a minute. So this will be the column which we have to predict, and this will be our y. So now we will separate our x and y. So y will be equal to new data 3, and then x will be new data dot drop. The column will be 3, and the axis will be 1. So let's run it, and here we can see x dot head. So see, we don't have the third column. Now the third column is ry here. So now we will split the data into training and testing data, and we will use train test split. So x train, x test, y train, y test is equal to train test split capital X capital Y. Test size will be 0.2, and I'm using random state as 0 for now. So we have the training and testing split of the data. Now we can make two arrays, ms and ma. Ms will store the mean square error of different models, and ma will store the mean absolute error of different errors. And I'm also, because mean absolute error and mean square error is kind of long, so I'm defining them as this, and mae equal to mean absolute wait a minute, what I'm writing, absolute error. So now we will code a function which will be train model. It will take a parameter model, then it will train the model, model.fit x train, y train, then it will generate a prediction which will be y pred, which will be equal to model.predict x test, then we will print the mean square error and mean absolute error, and also we will add these to the ms and ma array which we have made. Append msc y pred y test and ma dot append mae y pred comma y test. So our function is now complete. Before we move on, I'm thinking of separating this cell into two cells, because the function cell I like it to be different. So again, this is just my liking. You can make these both cells as same as cell and can divide. Again, purely your choice. So don't worry, this will not affect our performance. Now what I'm adding is will affect our performance, and first I will write it, and then I will explain why I'm doing this. Now I'm using a function which is np.nan to num. Why I'm doing this is because what happened is that uh, later in the video when we will code some models, you will see one of the model which throw the error if you don't include this np.nan to num. It will not execute and will throw error that the number is not a number, which is a kind of error which took me time to solve. So I came up with this solution. If you have any better solution, do comment and I will also look at your solution. So if you have any solution other than that which I have done, so do tell. Now I am running these cells, and again we have no error here for now. Now before moving on to our model, I'm thinking of renaming this function, because it is not only calculating or training the function, the model, but also it is calculating the accuracy, or you can say the score of the model. So it will be very good if we name it training and score with and model training and score, because it is training the model and it is also giving us the score of the model. So that's why I'm changing the name. Again, my preference, you can also keep it the train model name which we have used, or you can change it whatever it is. This is just my preference. So I am defining the model which is random forest regressor and I am using n estimators as 5, and then I will use model training and score and pass the model. So now let's run it, and it has shown us some error. What is the error? The function is not defined. Oh, I changed, and I haven't run the cell, so again my mistake. Here you can see we have the mean square error in the first line and then the mean absolute error. So we will get errors for every function every model we use, and the array will also contain but wait a minute, these array will contain these scores which are printed. So let's complete our models. Now we will move to our second model, which is lasso regression. So model will be equal to same lasso regression, and alpha is the parameter here, so I'm defining it 0.1, and I will highly encourage you to change these parameters to check what it does and what's the effect on score, so that you can know. Oh, it's lasso only, not lasso regression. So here we have the score of lasso regression. Now let's move to our third model, which is support vector regressor. So model will be equal to SVR. I'm leaving it on default parameters. Their kernel is already defined, degree is given. Again, these parameters you can change. So I'm not changing for now. So I'm using model training and score and model. Here we got the answer. Wait a minute. Now we will move to our fourth model, which is stochastic gradient descent. So model will be equal to SGD regressor and model training and score, that will be equal. There we got. Now let's move to our fifth model, which is Gaussian process regressor. Now for this we will first need to define the kernel, which will be dot product plus our white kernel. Then the model will be defined, which is Gaussian process regressor. The kernel will be equal to the kernel defined, and I'm taking random state as 0. Then we will call the same function. Now let's run it. Here you can see this warning. You can ignore it. It is not a big deal. But here I'm pointing out this because here you can see our errors are very less. It's in 10 raised to power minus 13 and 10 raised to power minus 7. So for the models we have tested and we are continuing to test, this is by far the most suitable model for our stock prediction. So but we will complete all the models because I promised. So then we will use decision tree regressor and then model training and score model. So here we got the output. Now let's code our seventh model, which is k nearest neighbor. So k neighbor regressor. Again, most of the models I'm using their with their default parameters. You can change it, and I will encourage you to change them. See if you can improve the accuracy of the model, and you will also learn something new. So again, my recommendation is that you should change the parameters and do some research, read some articles, and I will also recommend you to read the documentation of the sklearn library which I'm using. So they have some good examples. So let's first focus on our eighth model. Now our last and final ridge regression model. So now we will plot our losses of the different models. Now let's plot our losses. So for plotting, I'm using the variable bar width, which will be 0.2. Then we will use fig equal to plt dot subplots, and the fig size will be 16,8. br1 bar graph 1 will be np dot a range. Length of the mean squares, we will use plt dot bar np dot a range. Length len ms. Color will be red. Width of bar will be the bar width, and the label will be mean squared error. error. Then br2 will be equal to x plus bar width for x in br1. Then plt dot bar br2 ma. Color will be blue. Width again will be equal to bar width. Label will be equal to mean absolute error. Then plt.x label will be models, and font size will be 15, not 150, like 15. plt.y label will be our loss, font size equal to 15. Models will be equal to an array which has all the names of the model: lasso, support vector, stochastic gradient, I executed the function accidentally, don't worry. Gaussian process, decision tree, then k neighbors, radius neighbors, and then ridge regression. Then we will assign the x-tex or r plus bar width for R in range len ms, comma models, and then I need to show the legend, so I'm using plt.legend, then plt.plot. Now we have plotted the graph. Here you can see, you will see nothing for Gaussian process. Again, there is nothing like that. The Gaussian process has no losses. It has losses, but again, these are very low losses. Let me show you again the where we have predicted. Here, see, e to the power minus 13, 10 to the power minus 7. These are the magnitude of losses, which are quite close to zero, or again we can round that off to zero. So here radius neighbor and lasso regression are showing the most, you can say, error, and Gaussian process here it concludes that it's the best model to use for Netflix stock prediction dataset which we have been given. Again, it might not be best for other datasets. For example, if there is some discrepancy in data, or there is something which is like very big change in data, here you can see it is quite like it's rising graph and then it dropped. It could have worked, could not have worked, depends solely on how our data is given to us. So here we have complete notebook. We have completed all the parts of this notebook. So yes, our project is complete now. Thank you for watching the video, and if you like this video, do like, share, subscribe my channel, and also I would recommend to check this code out. I will link that in description. So if you like that notebook, if you like this code, please upvote on Kaggle also. Thank you very much for watching the video.